Hey, and welcome to this lesson on similarity. So we're going to build off of what we know about polygons and what we just learned about ratios. And we're going to apply that to a new concept called similarity. It's kind of the middle part between two figures being congruent or not being the same at all. They are similar. They're not totally different, but they aren't completely congruent. Essential question: what is similarity? How can we use it in geometric figures? So we're going to explain what that means for two figures to be similar, and how can we use the concept of similarity to prove two figures are congruent. And we're going to prove that two figures are similar. And here's our main definition of the lesson: is similarity. It's a new term we're introducing. Two figures that have the same shape are said to be similar. So two figures that have the same shape are said to be similar. I'm going to read this a couple times. Take this time to copy down this definition, put it in your notes, research it, Google it, maybe take a screenshot, do whatever you got to do to really understand what it means. So if two figures are similar, they have the same shape. When two figures are similar, the ratios of the lengths, so the lengths of the sides, the ratios of the lengths of their corresponding sides. So I have two sides. Instead of those two sides being equal in length, now they're going to have a ratio. So they're going to be, those two lengths are going to be compared to each other. And all the corresponding sides will have of a triangle, say, or any shape, will have the same ratio for all pairs of corresponding sides. So when two figures are similar, the ratios of the lengths of their corresponding sides are equal. So to determine if two triangles are similar, for example, we need just to compare their corresponding sides. Here's an example of two triangles that are similar, triangle ABC and triangle XYZ. If you notice, they are the same size. Notice how the angles, though, are the same degree. So in similar figures, the angles are congruent. However, the side lengths are different, but notice how they all have the same proportion. So 10/15 is the ratio of side AC to side XZ. And that ratio is equal to the side AB to the length of side XY, which is 6/9. Which all of these are going to equal 2/3. And BC's ratio is equal to, BC compared to YZ, that ratio is 8/12, which is also 2/3. So they all have a equal ratio, which is 2:3. So those two triangles are similar. The symbol used to notate similarity is this squiggly line here. Just a little squiggly line. If you're looking for that on the keyboard, it is almost in the top left corner. It's to the left of the 1 and right under the escape button and above the tab button. Hit shift, hit that little squiggly line. So here's another example. This example, let's say we don't know if these two triangles are equal or not. So the process of what we're going to do is we're going to find the ratio between corresponding parts. So it's color-coded here. AB corresponds to DE. So that means that we can write a ratio of AB over DE. And if we do that, we get 4/16. And we want to see if that 4/16 is equal to the other two ratios between the two corresponding sides. So then we look at the another pair of corresponding sides, BC and EF, is 7 over 28. And then AC to DF, which is 10 to 40. And if you simplify all those fractions, you will see that they all simplify to 1/4. Therefore, all the ratios are equal, and since the ratios of the corresponding sides are equivalent, then the triangles are similar. It's a little quick review of what was just discussed in this part of the lesson. Similar figures have the same shape, but not necessarily the same size. Same shape, but could be different sizes. The little squiggly symbol means is similar to. Two polygons are similar polygons if corresponding angles are congruent and if the lengths of corresponding sides are proportional. And last but not least, when 3 or more ratios are equal, you can write an extended proportion, which instead of just having two ratios set equal to each other, for example, if I had that and I had that, that is our normal looking proportion. An extended proportion just means that you're going to say that something else is also equal to those two things. So it's just one long extended proportion. You're just extending the proportion. You're saying that this ratio and this ratio are, yes, they're equal to each other, but they're both also equal to this next one, which I believe would be something like that. I suggest you copy all 3 of these things down, put them in your notes, study them, make sure you really understand them. And if you don't, come to the Math Cafe so we can talk about it some more.